Okay, 7-4, arc length and surface of revolution. That is always like a mouthful to me. I can't do it. So definition of arc length. Let the function given by y equals f of x represent a smooth curve on the interval a, b, and that is inclusive, that closed interval. The arc length of f between a and b is s. Okay, s is arc length. Remember sectors? Arc length. So s stands for arc length. Is the integral from a to b of the square root of 1 minus the derivative of f of x squared dx.
Which one of those two equations should we write down, or does it matter?
Well, one is x, one is on the x-axis, and the other is on the y-axis.
Which one's x? The top one's x, the bottom one's y?
Yes. So if you look at the picture down here, this would be something on the x-axis, and this would be something on the y. So they are exactly the same equations, correct?
Yes.
So it's just one is on the y and one is on the x. So I guess if you know that I can interchange x and y, you could write down just one. In my brain, I would probably only write down the top one. And I might put a little note that if x equals g of y, then use y. Note taking is a skill. I found myself in class, I would take notes during notes, and then when I was doing my homework, I would take notes on top of my notes.
Oh, like add stuff?
Yes, I would. At that point in time, it was like an erasable color pencil because they didn't have good erasable pens. But so I knew what I added later to clarify, to something that he probably said that I didn't pick up. I one time had an instructor that told me, you don't write what I put in front of you on the board, you write what I say. Because what I put in front of you, you can get right out of the book, right? Those little things that I might just say, you can't get that out of the book. But you got to write both. So are we good? That was a history teacher, or a math teacher. Okay, for example, find the distance between the points 1, 3 and 4, 7. Okay, well, I just asked you to find the distance between 1, 3, and 4, 7. So I didn't say what it was on, did I? No. So we're just talking about the distance formula, aren't we? Sure. I want to see how I want to approach this. Maybe I just don't want to do this problem. Okay. Well, if I ask you that you already wrote down. Okay. If I ask you to write the difference, like the distance between those, that would be d equals the square root, yes, of x minus x squared plus y minus y squared. And we've had this discussion before. This is the same as c equals the square root of a squared plus b squared, yes? So do you see where the square root comes from in the formula I just gave you?
Because it's the Pythagorean theorem.
Yes, the Pythagorean theorem and all that. And we are not a straight line, so we can't use this distance formula. So this is where the distance formula came from. Not the distance formula. This is where the calculus formula to find the length of the arc came from. So you don't need to write this down. This would just be what? 4 minus 3 squared plus 7 minus 3. Nope. You can yell at me. 4 minus 1 and 7 minus 3. Yeah. I did the no, right? And so I get 3 squared, so 9 plus 16. So I get 25, so I get 5. Okay, so if I were to plot these points, at 1, 3, I have a point, yes. And at 4, 7, I have a point. I want to know the distance between these two. Actually, I want to know the distance between these two, but I make a nice, what, triangle? A right triangle. So this is 3, and this is 4.
Yes.
And so it is a 3, 4, 5 triangle. Yeah. So that's where it came from. I don't really know why I have that there, but okay. Find the arc length of the graph y equals x cubed divided by 6 plus 1 over 2x from 1/2 to 2. So S is arc length. The integral from what to what? 1/2 to 2. The square root. I just wrote down that I didn't even write down, so I can't remember. 1 plus the derivative squared. Okay, so y prime. I hope you guys write 1/6. Didn't you? When you wrote it down on your paper? I would have written this as 1/6 x cubed plus 1/2 x to the negative 1. Wouldn't that be the easiest way to write that?
Except that's not what I did.
Oh, sorry. So the derivative would be what? 3 over 6, so 1/2 x squared. And then minus 1 over 2x squared. Correct? Okay, now I got to what with it? Square it. Unfortunately, yes. Before I square it, can I factor out a 1/2?
Yes.
Would that make this much easier to square? I think so. So 1/2, so we're squaring the whole thing. So 1/2 squared is 1/4. And then I have to FOIL. So times x squared minus 1 over x squared. So that'd be x to the 4th minus 2 over x squared plus 1 over x to the 4th. You guys agree?
Yes.
They don't.
Well, x squared times 1 over x squared.
Oh, I just did this. Be quiet, Mrs. Mick. Sorry. I just took them and said, oh, I have 1 and I have 1, so I have 2. I didn't multiply. X squared times 1 over x squared is 1, yes? So 1 and 1 is 2. There we go. So now I plug this in. Oh, I could add 1, can't I? Can I add 1? I was just looking at their work. I don't quite agree with it. When they plugged it in, their 1 disappeared. Like, it's gone. So we have 1/4 x to the 4th minus 2 plus 1 over x to the 4th. Okay, so, well, we got to distribute the 1/4, don't we? Because our only hope is that we can distribute it and factor it, and it's a perfect square trinomial. That's our hope, right? So I have the square root of 1 plus 1/4 x to the 4th minus 1/2 plus 1/4 x to the 4th. So 1 minus 1/2 is a half, correct?
Yes, 1 minus a half is a half.
Okay, so now I have, I'm going to write this, I'll do it. I'm going to run out of room. I'm going to have to erase and start. So I've got 1/2, we're doing a lot of prep to find this integral, plus 1/4 x to the 4th plus 1/4 x to the 4th. I don't like all the fourths. How about you? No. I think we need to factor out well, do you guys want to factor out a fourth? So if I factor out a fourth, I would get 2, right? Plus x to the 4th plus 1/x to the 4th. Well, if I rearranged it, don't I have something similar to what I started with? Well, okay, so I'm just doing clues, right? If x to the 4th minus 2 plus 1/x to the 4th came from x squared minus 1/x squared quantity squared, wouldn't it come from the same, wouldn't this be the same thing? But with a plus? Yes?
Yeah.
Yeah. So now I can substitute this back in for that, can't I? Oh, I forgot my quantity squared. So I'm just going to go from here to here. I'm going to take the square root of this. What's the square root of 1/4? 1/2 times x squared plus 1/x squared dx. So do you think that's going to happen a lot? It'll happen more than you think it will. But is it always going to happen? No. Okay, so now we have to take the integral. Well, the half's going to come out, yes? I feel like I'm going in circles. Can I erase all this stuff? Do you guys got it all down?
Yeah.
Okay. Okay, so I have 1/2 the integral from 1/2 to 2 of x squared plus x to the negative 2 dx. So then I would have 1/2 1/3 x to the 3rd plus, well, add 1 would be, it wouldn't be plus, it would be minus, wouldn't it? So it'd be minus 1/x from 1/2 to 2. So I have 1/2. Plug in the 2 in, I'd have 8/3 minus 1/2 minus, well, that'd be 1/8 times 3, so 1/24 plus, because you're subtracting the 2. And 1/1/2 would be just 2. So now I get lovely common denominators. So 64, because 24 is my common denominator, right?
Yeah. Wait, yeah.
So that'd be 64 minus 12 minus 1 plus 48. So 102 minus 13. 189. I know we did that, right?
Let me guess. We didn't get the same answer. Did we?
They have 33/16.
Are they both divisible by 3? Well, I know you get 16 from dividing 48 by 3, about 189.
Well, they're both divisible by 3, yes. 60, 63/16. So we should have divided earlier, right? But okay, so I've got, if I plug in 2, yes? Because this is what they have, we have exactly the same thing they do here. So something happened. So if I plug in 2, 2 cubed is 8. So I get 8/3. And I plug in 2, I get minus 1/2. And then we're going to subtract, so it would be minus and a plus. No. Yeah, it'd be a minus and a plus. So when you plug in 1/2, 1/2 cubed is 1/8 times 1/3 is 1/24. And then plug in a half, so we plus, first of all, it'd be 1/1/2, which would be 2. So our common denominator, okay, let's just do this and do this. So this would be 6, right? So this would be 6, so that'd be 16 minus 3, which would be 13. Okay, that's what they have. This would be 48 minus 1, which would be 47/24. So this would have to be multiplied by 4, which would give me 52. This would be plus.
Yeah, you'd be adding that.
Yes? But they subtracted it. No, they added it. So when I add that, I get 9 D9.
Yeah, and then over,
How did it over 48?
over 24 still, right?
Well, when we multiply by a half. Like,
Oh, right.
so then we would get our 33 over 16. But how did I add wrong?
What answer are you supposed to do again?
33 over 16.
33 over 16 is the right answer. So we got the right answer when we did it in pieces, but we should have got the right answer when we did it just 24. So what did we do wrong? So let's go back over here. So for common denominator is 24. So 8 times 3 is 24. Yes? So 8 times 8 is
64.
64. What did we subtract? I'm pretty sure it wasn't 12.
Well, well, we combined it with the 1 over 24 to be 13, but we still had 12.
Did we have 12 that first time?
Yeah.
Okay, minus 1. And then 24 would be 48.
Yeah.
So you have to add the 64 and 20 and 48, which would be 2, which would be 102. Minus 13. So that'd be 9. Oh,
It would be 112, not 102. Right?
yes, it would be 112. And I didn't subtract right. So that would be 99. Okay, so sometimes we mess up our math, right? And honestly, what we just did right there was like a huge learning process to be able to go through and evaluate, okay, why didn't this work? Because we can't add sometimes.
Fair enough.
It happens. I would say if we could add, subtract, multiply, divide 100% of the time efficiently, we'd be good. So we found that this arc length was 33 over 16. Now, we should have a unit if they had units or whatever, but that's it. That's what you're doing.
Can't wait.
The same for tomorrow, too.
No, because you need to find the area, yes. So let's go to the area. Here's your formulas. Now again, the top one is for the x-axis, the bottom one is for the y, or the top one is for around the horizontal, and this is around the vertical. But are they the same thing happening? Yes. So capital S, and sometimes we use capital S for, and they are using it because it's area, so it's capital, but it's of a surface of revolution. So it's basically surface area. We found volume, we might as well find surface area, right? So it is capital S equals 2 pi from A to B or C to D or whatever to whatever of R of X square root of 1 plus the square root of 1 plus the derivative squared dx. Now, are those really similar? What's the only thing added? The 2 pi, yes, and the r. R is the distance between the graph and f of x on the axis of revolution. So R is right there. And it starts off little and then it ends up big. Can it start off big and end up small? Yes, the whole point is it constant? No. They give you a definition for surface revolution. It's funny. When the graph of a continuous function is revolved about a line, L, the resulting surface is a surface revolution. Oh, okay. We good? Okay, so find the area of the surface formed by revolving the graph of f of x equals x cubed on the interval from 0 to 1 about the x-axis. So we need surface revolution is 2 pi from what to what? 0 to 1. And we're about the x-axis, so we're dealing with x. So this would just be an x. The r of x, the space here would just be x. So x, square root of 1 plus, well, the function is x cubed squared. Oh, the book has a 3. No, they don't. Never mind. Oh, I forgot. We have to find the derivative of that. Yes? How about that? F prime of x. So f prime of x, we always have to come off to the side.
Well, wouldn't it just be 3x squared?
It'd be 3x squared. Yes. Sometimes they're really easy, sometimes they are not. So the integral, and you will find me leaving my 0 to 1 off a lot. So 1 plus, well, that would be 9x to the 4th. Okay, so now what do you want to do?
Where's your 2 pies?
We're probably going to have to say what? U is 1 plus 9x to the 4th. So u prime, 36 x cubed.
Where's your 2 pies?
Oh, wait, this is cubed. This is the function. I apologize. I said x, but it's the actual function because that's going to give you, the function is x cubed. So it's x, like that is the function. Does that make sense? Because that x is going to give you this distance. Every time I give you that distance, it's going to give me that. Does that make sense? Okay. So we're missing a what? 36. So we're going to have to bring out here a 2 pi over 36. And so I have 2 pi, oh no, I have pi over 18. And the derivative of u to the 1/2 du. So I said derivative, integral. I know I said it, didn't I?
You did say that.
So the integral, so add 1 would be 3/2, right?
Yes.
So it'd be 2/3. 2/3 x to the 3/2. Oh, not x. I'm really trying to shortcut. U. So pi over 18 times 2/3, because I'm going to bring 2/3 out. You guys agree with that?
Yeah.
Okay, and then we're going to have 1 plus... Do you guys want to put it back in the square root, or do you want to leave it to the 2/3?
Doesn't matter.
No. I think it'd probably be easier the 2/3, don't you? Oh, yes. Yes. But I think it might be easier to...
Do it like that.
Yeah. Okay, so out here we got 9 pi over 27. Right? And so when we plug in 1, well, we get 4. I mean, not 4. We get 1, 9 plus 1 is 10. So 10 to the 3/2. And then minus 1 to the 3/2, or minus 1. And anything after that would have to be put in your calculator, and you would get approximately 3.563. And I'll let you, you're going to have your calculators on this one.
We do get it for the test. Oh, good. Too bad I don't know how to use my calculator.
Well, I haven't showed you how to use it. Like,